experiment involving intermolecular forces and their effects on solubility. So what are the main when we talk about a substance dissolving or being soluble? So we know that when we mix two substances together to be a liquid and a liquid or a liquid and a solid, when we see a homogeneous solution, then we know that that thing dissolves. But when we see two distinct substances, like the mixtures do not form a homogeneous solution, then we know that that substance is insoluble. And therefore, so we know that solubility is a physical process, just like evaporation as we saw the last time. And there are chemical entities that control these physical processes that we see. And so again, here the role of intermolecular forces of attraction between molecules of a substance will determine whether that substance will interact with another substance to dissolve or not. So we know that water is a universal solid. Basically, most or all living systems depend on water to dissolve and transport different substances in the body. And so today we will also use water and combine it with all other different substances. Like we have a mixture of solids and liquids, and we just want to see how those substances, whether they dissolve or not dissolve in water. So I will take, for example, naphthalene. It's a solid, and I am going to put it in a test tube that has 2 milliliters of water. So this is just a few crystals of the naphthalene salt, and I am going to put it inside the water and try to mix it. So I'm shaking it. Alright, so let's see. I did let it settle, and I want you guys to see. So as you can see in this test tube, we still have some solid, and we also have a liquid. So with your observations, you can write whether this substance is soluble in water or not. Okay, so we will go to the next solid, and this is sodium chloride. So sodium chloride is a common salt, and we kind of know from how we often use it whether it's soluble or not, but we will confirm in this experiment. So I put some of the sodium chloride in this test tube that has water, and I'll shake it again. Alright, as you can see, we have a homogeneous solution. And next, we will do sodium sulfate. It's another salt. And kind of do the same thing. Add the sodium sulfate into the water. Shake the solution. And let it sit. And this one, as you can also see, we have a homogeneous solution. Alright, so next we will take calcium chloride, do the same thing, put the salt inside the test tube that has water, and we'll mix it. again, as you can see here, we have a homogeneous solution, very clear. Now go ahead and dissolve sodium carbonate, and we'll see what happens. Here's our salt. We'll also mix it. Again, as you can see here, we have a clear solution. And let's go to calcium carbonate. Just a small amount of the salt. Put it in our liquid, mix it. This is interesting. We see a milky substance or a cloudy suspension. So would that be soluble or not? And the last of the solids, we have glucose. Glucose in the test tube. Mix and see what happens. Well, as you can see here, we also have a clear solution. Alright, so for the liquids, it might be a little hard to see because we have two colorless things being mixed up. It was easy with the solids because we have a white solid substance and then clear water, colorless water. But now we have to see if something is insoluble, then we have to see like two different layers of the two substances. But if it's soluble, we don't expect to see the two separate layers. We see a homogeneous solution. So this is isopropyl alcohol. Now I'm going to take approximately 8 drops. Okay. And I will use a stirring rod just to make sure. Or I can just shake it. And with this, we see a clear solution. So this is M-butyl alcohol, and I'll also take about 8 drops, just a few drops. This is still 2 ml of water. Just kind of mix and see what happens. And this is an interesting one. The solution is forming 2 different layers. And we can do the same for isopentyl alcohol. Mix it. Same thing we saw with the N-butyl alcohol. We have two separate layers. This right here is cyclohexyl alcohol. Take the same amount. Mix the solution. Just as the other two before, we also have two separate layers. This is dichloromethane. Let's see what happens. Take 8 drops. And mix this one. We have two separate layers again. Acetone, as you can see, acetone forms a clear solution. Almost done. And this is 2-octanol. And this gives us two separate layers. Finally, we have hexane. And as you can see, hexane also has two separate layers.